Hello everyone. Today we will study about the projectile motion. Very interesting topic, and it will definitely help you to analyze the situations around us, right? So what is a projectile? First we have to discuss what is a projectile, and then we will be considering the two types of projectile, right? So projectile is a body which when once thrown in air moves under the effect of gravity alone without being propelled by any engine or fuel, and it follows two-dimensional motion, right? So what are the different points? I'm not going to write the whole statement as it is. I'll write the main points, right? So first thing is when thrown. When thrown once, moves under the effect of gravity afterwards. So this is the first important point, that when this body is once thrown, it moves under the effect of gravity afterwards, not under the effect of any fuel, right? So this is not under the effect of any fuel, right? So it has to go by itself once thrown. First thing. Second thing, that means it must not be propelled by any fuel. Third thing which is very important is that it follows 2D motion. That means you can say that this motion is a combination of horizontal as well as vertical motions. So it's a combination of horizontal motion and vertical motion. So it's a combination. So I must mention that this is the sum of these two motions, where the horizontal and vertical motions are independent of each other. So this horizontal and vertical motions are independent of each other. Right? So from here you can get an idea. This is a question often asked by students, that when a ball is thrown vertically upwards and it comes back to the thrower's hand, is it a projectile? The answer is no. Why no? Okay, these 2 points are followed in this case, but this point is not followed there. In case of a ball thrown vertically upward, when it reaches back to the thrower's hand, it's not a combination of vertical and horizontal motions both. It's just a vertical motion. So that's why it cannot be called a projectile. I'll just mention it here. Ball thrown up, comes down. This is the ball. It's not a projectile. The reason being that only 1D motion is here. So that's not a projectile, right? So that's about the definition of projectile and the projectile motion, right? Now we have in our course the two types of projectile motion. First is the oblique projectile and second is the horizontal projectile. So let's first take the oblique projectile. So what is an oblique projectile? Suppose I want to throw something. Say for example, I am throwing this object, right? And I am throwing it like this. That means I have initially given it a velocity in some direction with the horizontal. This was the horizontal direction. I have thrown the object like this. The object is thrown from here. It falls down at some horizontal distance from me, though it has covered some vertical height also. So this is the case of the oblique projectile, right? So I can mention it oblique projectile. We'll discuss this in detail here, right? So these are the two kinds. First is oblique, which I just gave you a demo of. Second is the horizontal projectile. Horizontal projectile is, suppose I want to throw an object in just horizontal direction. So I am throwing this in horizontal direction. So I have thrown it in horizontal direction. I have not thrown it at some angle with the horizontal. So this kind of projectile is called horizontal projectile because the angle with the horizontal is 0. But once I have thrown it in horizontal direction, it falls under the effect of the gravity, right? Falls at some distance from me and it has covered some height. So that means it is a combination of again the horizontal and the vertical motions, right? So this second case is horizontal projectile, which we'll take later, right? So oblique projectile, I have already told you what it is. Let's see the diagram. So this object, right? This object is given some initial velocity u at an angle theta with the horizontal, right? So when this is given some initial velocity, what will happen? It will cover some height and fall at some distance from this point O. Now under the effect of gravity, it has covered the vertical height h. This is the maximum height covered by this, right? And it reaches at point B, suppose. The maximum horizontal distance traveled by this object is OB, and this is called range, right? Now, when this object is projected, when it is thrown from point O, it has this velocity, okay, u, right? And it is at this angle theta with the horizontal. Now, just recall the concept of vectors, that if we have a vector A in this direction, this is theta, then what is this component along horizontal direction? This is A cos theta, you remember? Yes, we can say that this is the horizontal component or x component of vector A, right? Similarly, we know that this vertical component is denoted by AY, and this is A sin theta, right? Similarly, if we talk about the components of this velocity, this horizontal component of velocity is u cos theta, right? And the vertical component of velocity is u sin theta, right? So in this diagram, you can relate these two cases because you have already studied this. Now you can apply this in the diagram. That means here, this initial velocity along horizontal direction is u cos theta. And the vertical velocity along initial vertical velocity is u sin theta. Let's consider an arbitrary point during its journey. Suppose I have taken this arbitrary point P during the journey. Up to this point, how much horizontal distance it has traveled? See, this is the horizontal distance it has traveled. Yeah. And this is the vertical height it has traveled. Say this is y. So I can write that x and y are the coordinates of point P. Right? Suppose it has traveled, the time elapsed during this journey from O to P is time t. So I can mention this. Right? Now, when we are analyzing this case, we need to understand that this motion is a combination of horizontal motion and the vertical motion. So that means we need to apply all the rules and regulations to the horizontal and vertical motion separately. So for that we need to draw a table. Let's mark that table. For horizontal, I can mark this as H, and for vertical, I can mark this by V. And for these cases, what will I do? I will write initial velocity, final velocity and acceleration. So initial velocity, acceleration and then final velocity. Right? So let me find these things for these two motions which are giving result to this. So I am finding this, first case, second thing and third thing, right? Now, initial velocity, what do I mean by initial point here in this diagram? The initial point in this diagram is O, right? So the initial velocity in horizontal direction is u cos theta. So this is u cos theta. And initial velocity, that means velocity at point O, in vertical direction is u sin theta. So this will be u sin theta. Let's check the acceleration. I told you that when I am throwing something at some angle with the horizontal, I have thrown it. So at that point when I am throwing it, I have thrown it, that means I have no control afterwards. It's under the effect of gravity alone. So for vertical motion, it's under the effect of gravitational acceleration. But for horizontal motion, there is nothing which can provide acceleration. So that's why in this case, the acceleration along horizontal direction will be 0. In this case, the body is initially thrown up and then it falls down. So once this is thrown up, right? So at the point when it is thrown, at this point, the direction of motion is up and the body finally comes down under the effect of gravitational acceleration. So at the point, when we are considering the whole journey, so at the point of initial point, we consider the direction of acceleration. So at initial point, upward direction of motion is there, but the acceleration is downwards. So what will be the sign of acceleration due to gravity? This will be minus g. Now what will be the final velocity in case of horizontal direction? We know that the acceleration is not there. So the velocity will remain same. But in this case, acceleration is there. So we can use the formula v is equal to u plus at. So what will be the final velocity? We can calculate from here. Initial is u sine theta. This is minus g and t if we talk about point P. So final velocity at time t will be u sine theta minus gt. Right? So once this table is ready, it is very easy for you to derive all the 5 cases. What all cases we are going to derive? I am just mentioning here, then after I will have to rub the board to get some space for deriving those equations. So I am rubbing this part at least. Yeah, and the first derivation which I am going to do is the path of the projectile, or you can say the equation of the trajectory. So the first derivation is equation of trajectory. What does trajectory mean? It means the path of the projectile. Right? Now, this trajectory, this path is a combination of horizontal motion and vertical motion. Right? So that means here we will use both horizontal and vertical case, right? Because we will be using this table. So at point P, if we consider the horizontal motion, we can find the time taken to reach point P. Time is what? Distance upon speed. So what is the distance traveled in horizontal direction if we are considering horizontal motion? What will be the time taken to reach point P? If we are considering horizontal motion, the distance will be x. Speed in horizontal direction is u cos theta. So this is u cos theta. Now we will consider the vertical motion at P. So vertical motion at P. Which equation we are using here for the trajectory? S is equal to ut plus half at square. So S is what? At point P we are talking. So at point P, what is the vertical distance? We are talking about the vertical motion. So at point P, what is the vertical distance? Y is the vertical distance. What is the initial vertical velocity? Initial vertical velocity is u sine theta. T is the time taken to reach point P. I can replace this T from here, but I will do that in the next step. For acceleration in vertical direction, I will write minus T. So what will it be? Minus half g t square. Let's mark this as equation 1. This as equation 2. Right? I can solve the next part here. So from here to here, we don't need this now. So I'm just rubbing this part. Now, what will I do? I can put the value of t from here to here because this time is same. Whether we are talking about this vertical motion up to point P or we are talking about the horizontal motion till point P, this time will be same. So I can write from 1 in 2. I am replacing the value of t. So this will be y is equal to u sine theta x upon u cos theta minus half g x upon u cos theta whole square. Right? So from here, I can write it, u cancel. So this will be tan theta into x minus half g upon u square cos square theta into x square. Now look at the expression. This angle of projection, this theta is also called as angle of projection, right? So I can write here theta is the angle of projection. So this will remain the same. Whatever the direction I have given initially, this will remain the same. So this is a constant. I can mark this constant by P. I am replacing this tan theta constant by P. Now if I look at this is constant, G is constant, Q is constant, cos square theta will also be constant. So I can write this minus Q x square. This is the equation of parabola. So a projectile follows a parabolic path. I hope this is clear. Why we have taken both the motions here? Because path or the trajectory is a combination of both the motions. That's why I have taken this time t, put the value in this equation, and whichever motion we are considering, we have to refer to this table. Right? Now let's move on to the second derivation, and that second derivation will be height maximum. Children, this is very easy if you understand the logic behind these equations. You just need to remember which motion are we considering and why. And then refer to this table carefully. So second we are finding is maximum height. Now think of the case where out of the three equations we can take benefit of its maximum height. So we are talking about height. Which motion should we consider? I think you must get this instantly, that when we are considering about maximum height, we must consider the vertical motion. So just mention for yourself. So at maximum height, if we are considering the vertical motion, what will be 0? It must come to your mind that the velocity at the highest point will be 0. So I can use the equation where I have final velocity along with the initial velocity, right? And I want to find the distance. So which equation we are left with? We are left with, and we are using this with vertical motion. So let's say at point A, which is the highest point, what is the final vertical velocity? It is 0. Yes, that we know. This final velocity we have written for point P, not A. At A point, the final vertical velocity is 0. That's why it comes down again. Yeah. Initial vertical velocity, look at this. U sin theta. So I'm just squaring it. Now, what will be the acceleration? It will be minus g. What is the s? S is the distance traveled. That is h max. So from here, you will get, I'm squaring it. This has shifted on the left side. So what is the formula for h max? This will be u square sin square theta upon 2g. Remember the formula? Directly very important for numericals also. Okay, so this is our second derivation. I hope this is clear. Third derivation we will take the time or maximum height. So again, if we are talking about time for maximum height, what can we take benefit of? The final velocity, vertical velocity 0. So what formula will we use? Very simple. V is equal to U plus AT. Again, we are considering vertical motion because we are talking about this height case. So we'll consider vertical motion and we have to refer to the table written. So final velocity at the maximum point is, maximum height is 0. Initial velocity is u sine theta. Acceleration is minus g. And for t, what will I write? Time for maximum height. Right? So what is the time for maximum height? This will be u sine theta upon g. So this is our second derivation. Now I have to find the total time taken during this flight from O to B. So that is called as time of flight. So these are the three cases which you have to write. Fourth is time of flight. But when we are taking the time of flight, it again comes back to its original position. Right? So the original question means with respect to vertical, if we are talking, so it started from ground, it comes back on the ground. So if we are talking about the vertical motion, the vertical displacement is 0. Horizontally, it is displaced from O to B. But vertically, some height and then again on the ground. So vertical displacement is 0. So again in this case, we will consider the vertical motion and we will consider the whole journey. Why? Because we are considering the time of flight. This I am denoting by TF. And we have to remember this, that we are considering vertical motion. We know this formula. Why we are using this, it will be clear. Because for vertical motion, the displacement from here to here, the vertical displacement is 0. It was on ground initially. It came back to the ground. Right? So this is 0. Initial velocity in vertical direction. Remember this. This is u sine theta. T I will replace by time of flight. Acceleration I will replace by minus g because I am considering vertical motion. Solving this, if I shift on this side, half g tf square is equal to u sine theta into tf. I can cancel one tf over here. So from here, what is this? 2u sine theta upon g. Right? So this is giving the formula for time of flight. And the last derivation. Last is for the range. And what is range? The maximum horizontal distance traveled by a projectile is called range. Now for range, what motion should I consider? I think it must click your mind instantly that when we are considering the horizontal motion, we'll consider here horizontal motion. That means we have to refer to this horizontal motion table. Now, in horizontal there is no acceleration. So we know the formula. Distance is equal to speed into time. Now what is this distance? This distance is range. What is this speed? Which speed are we talking about? Which is helping it in covering this distance r, which is the horizontal distance. So velocity along horizontal direction is important here. So this will be u cos theta, whether it is initial or final, it is u cos theta because there is no acceleration in horizontal direction. Now what is the time and this will give me u cos theta. Time of flight is 2u sin theta upon g. Now what is this? 2. I can write it u square upon g, 2 sin theta cos theta. And 2 sin theta cos theta, there is a formula in trigonometry. This is equal to sin 2 theta. So the formula comes out to be r is equal to u square sin 2 theta upon g. So this is the formula for range. Basically this oblique projectile is complete here, but we'll take some 1 or 2 cases related to this here only in this video. Okay, so I'm just rubbing this and we are taking those 2 cases. I hope this is clear. Now you have to remember these formulas directly, right? Because there are questions where you need to know the formula directly. So first is that the sum of the angles for which the range is same is complementary, right? You can say the special cases, or you can say important note. Better to write important note. Number 1, range is same if the sum of the angles of projection is 90 degree. So let's take the 2 cases. In one case, suppose the angle of projection is theta 1, right? This is applicable for the case same initial velocity. This is important here. For same initial velocity case, this is applicable. So first is this. Suppose if the second case, the angle of projection is -90 minus theta 1. So let's consider this whole angle as theta 2. So they are saying that the range will be same in this case. So I'll draw this diagram in the same figure. That will help you in understanding better. So if I'm saying that I'm projecting it like this. So this is the second case which I have drawn here. The initial velocity is same in both the cases, but the angle of projection in this second case is theta 2. Then they are saying that the ranges are equal. Hope you understood. Now here, this R1, what is the formula for R1? U square sin 2 theta. So I am taking for the first case, so this will be 2 theta 1 upon G. If I am taking the range for the second case, this will be sin 2 theta 2 upon G, right? And I told you that if theta 1 plus theta 2 is 90 degree, then theta 2 will be 90 minus theta 1. Yes? So I can write this as equation 1, this as equation 2, and this as third. So if we put third in 2, right? R2 is u square sin 2, sin t minus theta 1 upon g. Yeah. So this is R2 is equal to u square sin 180 minus 2 theta 1 upon g. And sin 180 minus angle is sine of that angle. You know that? So I can write the formula here. Sin 180 minus angle is equal to sine of that angle. So I can write here R2 is u square sine 2 theta 1 upon g. And this is what? This is equal to R1 from equation 1. I hope this is clear. So this was the first important point. And the second important point I'm going to tell you now. That second important point is that the energy is conserved during the motion of a projectile. So second point is energy is conserved. Total energy is conserved. So what does that mean? If I am considering this projectile, this is point O, this is point A. I am taking both the points, the lowest point and the highest point. Right? So let's take the potential energy. At O. What is the height of the point O? This is 0. So potential energy at O is 0. Now if we talk about kinetic energy, the energy will depend on this initial velocity. So this is half mu square. Yes. So what will be the total energy? Obviously 0 plus half mu square. That means half mu square. Now let's consider the point A, which is very important here. At point A, what is the potential energy? Potential energy is half m into velocity square. Now at point A, does the object has any velocity at point A? Vertical velocity is 0, but it has which velocity? U cos theta velocity. Right? Sorry here. Potential energy is mgh. So I have to write this potential energy by mgh. But if I am writing this kinetic energy, this will be half m into velocity square. So which velocity is there? This will be u square cos square theta. So I am just not skipping this step. This is u cos theta whole square, and this is half m u square cos square theta. If I am writing potential energy, this will be mg h max. So this will be mg. What is the formula for h max? This is u square sine square theta upon 2g. Yes. So what will it be, beta? So this will be cancelled. Gg will be cancelled. Now what will be the total energy? Total energy is the sum of potential energy plus kinetic energy. How will you do that? Just a little of trigonometry. So this is half mu square sine square theta plus square cos square theta. I can take this half m u square common inside the bracket, sin square theta plus cos square theta. What is the value of sin square theta plus cos square theta? It is 1. So the total energy comes out to be same as point O. So we can write down this thing, that since the total energy at O is equal to total energy at A. Therefore, total energy is conserved. In projectile motion. I hope this is clear about oblique projectile. So this was all about the oblique projectile. Hope you enjoyed this. You'll be able to understand many of the phenomena occurring around us, because we know that javelin throw and long jump, these are all the applications of this projectile motion which we often use in sports. That's all for now. Thank you and have a nice day.